streaming. It's going. Yeah, so like, easy.
Welcome everybody on our 15th class. I'm glad you're still turning up, even though it's pretty much in the middle of the holiday season. So my name is Tom Breza and I'm the host. There are two people mostly who are with me, is Oliver and Tristan. They are teachers and obviously very experienced developers. So that's happening thanks to them pretty much. So again, thank you very much for coming. Just a reminder for those who are first time or for the people who hear us on the internet. This is a weekly class. It's free of charge. If you want the latest updates, please do follow me on Twitter. My tweet handle is xxbms. You can find that on our brand new spanking website, which Oli did for us. One of the important things which I want you to bring attention to you. First one is Tristan MacBook is basically almost on its last leg. Last week the keyboard basically packed up, so I had to quickly find one of my old wireless keyboards and supply it to Tristan so he could basically do the slides. So what we're doing is we created a GoFundMe page, because this event is free, we're benefiting lots of people. So we hope that we manage to raise enough money to basically, as a thank you from students, I'm students the same way as you, to buy this guy a proper machine over time. Another one, I don't know how many people read the blog. What's happened is, it's a little bit bigger thing. We've done a bit of head scratching and see how we're getting on. It turns out that we're getting quite slow, but above that, which wouldn't be a problem, but above that, the class is basically splitting. Yes, there are people who are going really well, they keep up with the material, and there are people who don't. Plus, there are new people who are coming, so their first time, they would like to join the course, but they're discouraged. They say like, oh, I'm in the middle of the course, I don't want to join, I won't understand. So we will try to find a way to address that. So what we're trying to do is introduce a small change, well, big change. First one is today will be the last class for this module where we will give you some new information. The next class, so the following week, we will do a part of the class will be revision, and then we will do a module test. It's not like the end of the exam from the previous class, because we didn't cover all the material. It will be just a module. Now, everybody is encouraged to take the test. These people who pass the test will be welcome to a module 2, which will try to go on a faster pace, cover more advanced topics. People who will fail the test will encourage, and because we'll be starting another the basic module, we'll encourage those people to basically go there. And obviously the new users will have the opportunity as well to join us. So people who follow up, bingo, you go further. People who struggle, stay and basically give yourself time. It's not the race, just do what basically will work for you. Additionally, we're trying to think, because there was lots of positive feedback that people want to have exercises. So to address that, what we want to do is we want to create within the week. So for example, if we have a class on Tuesday, so same week we want to create a session later on, let's say maybe Thursday, other day, where you can meet up and just do exercises, nothing else. There won't be Tristan who will be going, or Oli or anybody else who will be going and doing like a lecture, but it will be just simply you sit on a bum and you do the exercises. Yes. So we hope that will have a positive impact on how you learn.
Can you make the exercises available outside of the sit down?
I suspect. I mean, the idea is for you to. We're not trying to like hide it. Yes, it is available to everybody. The only thing is that the reason behind that we're trying to make it more like organized, so we take away the troubles which people mostly have when they go home. You try to exercise, you don't know whether the exercise is too difficult, too easy, you're stuck and you don't know what to do, and then you say, I give up. Yeah. So to counter that, for the, I mean, some people might be better, some people might be worse. So that's the reason what we're trying to do. It's not mandatory, nobody have to go. But if you think, oh, I don't understand this subject, I'll, let's say, gather a group 5, 10, 3, whatever people, and together we might address the exercise. If it's easy, fantastic, yes. If you understand better, you can explain to somebody else. If somebody else understands, maybe explain it to you. So that's behind. So yes, obviously, if we have some exercise, they will be shared. It's no problem.
So they'll be on GitHub.
Yes.
So in terms of guidance, our plan is that we'll also mostly all guidance in person. But technically speaking, if you're able to just go and grab them off GitHub and do them, then of course you can. You probably don't need to if you're able to just do it.
So that's pretty much on the change. By the way, did I say how much did we raise? We raised so far £330. So thank you very much for those who. That's on the subject of the laptop. Finally, it's not finally. Sorry. Please RSVP for the further classes so we can get a bigger rooms. So the next class is 14th and 21st of August. It's happening here. There will be 1 or 2 classes which won't be here, and then I'll be talking to Ole. I think he can hopefully get us to Mimecast. For those who need licenses, I have still the new batch, plenty of licenses. Email me. Subject Sea Lion license in the body, your name, surname, email address, and I will email you a copy of the license. Obviously, please stick your name on the paper if you want your attendance to be counted. If there's a mistake, correct it. If you're not there, add your name. And obviously, after the class, we're going to pub. Thanks very much.
Just one question. Random quiz.
Yeah.
What kind of quiz? Is it? Multiple choice, programming?
You'll see.
It will be a mix. It will be a mix of various different kinds of questions.
So we need a laptop. So.
Yeah, please bring a laptop.
So I'm giving you Tristan.
Yeah. What is the license for?
Sea Lion. IDE.
What is it?
It's the program which you use to write, programs.
The C++ integrated development environment like Visual Studio or VS Code, it just happens to be commercial, but they provide us with confidential licenses. And we use it primarily because it works on Windows.
Yeah, so just to, I guess, expand a little bit on what Tom was saying about this idea of having sessions where we can just do exercise and things. I don't know about you, but when I'm learning something new, I read it and I see an example, like a worked example. I think, okay, yeah, that makes sense. And then I do an exercise myself and I've got the example there and I think, oh yeah, I get this. And then later, I come across something that's like that and I don't even know where to begin, right? Because it seems easy enough when you've got the example right in front of you, but trying to do it sort of independently yourself, to have actually learned it, suddenly you realise, oh, maybe I didn't actually take that in as well as I thought. So obviously in these classes I can only really got to interleave the exercises and the new materials, so I can only give you little sort of snippets. But if we have dedicated sessions, then we can have sort of more in-depth exercises that can take the whole couple of hours and really get to know things very well. So is that, it's completely optional, obviously. Well, this whole thing's optional. Nobody's making you be here. This isn't school. But yes. Anyway, that's still to be decided or finalised anyway. Normal. So I assume everybody's been here before, right? Nobody's new today. Excellent. So I'll skip the first couple of slides that I always talk about. Last time we were here, we talked about delegating constructors and we talked about destructors. Does that all sound familiar? from last week? Yeah, good. So this session, excuse me, we're going to finish off all our discussions about special member functions that we've been talking about the last few weeks. We had copy assignment operators left to go. We're going to talk about the rule of n, where n is 3, 5, or 0. And then finally we're going to talk about enumerations, which are another kind of user-defined type that aren't the same as structured classes. They're a sort of different kind of thing. So we'll talk about enumerations, and that will sort of round off our introduction to C++. And then after that, so next week, as we said, we'll have a revision session and so an assessment of sorts. And then after that, still to be confirmed, but the idea of the plan at the moment, as far as, unless it's changed, is we'll have a block, perhaps 4 weeks, on object-oriented programming. So classes, inheritance, virtual functions, interfaces, all that sort of thing. That sort of fun stuff. Yep. Sound all right? Cool. Well, if not, then this is how to tell us that it sucks. That idea sucks. Please do, but be nice. Don't just go, you guys are rubbish. I've had those and they're quite disheartening. Anyway, let's talk about copy assignment operators, first of all. So in the last few weeks, we've talked about default constructors, or constructors in general, default constructors in particular, copy constructors and destructors. So let's get a head start on that revision next week. You're going to tell me what a default constructor is.
Member function.
It is a member function, yes. All right, let's take a step back. What's a constructor?
It's the constructor that is provided for you if you don't do one yourself.
So a default constructor is provided for you if you don't write any constructors yourself. That's correct. So a default constructor, what I was looking for, is one that takes no arguments. And as you say, you will get a default constructor. The compiler will write one for you, if it can, if you don't write any of your own constructors. Okay, what's a copy constructor? No, let me ask another question. When is a copy constructor used?
When you need to copy a variable.
When you need to copy a variable.
To use the options of the variable class.
Sorry.
We need to use the member variables of another constructor.
You need to use the member variables of another constructor.
So it initializes member.
Okay. So
In general, but pass by value is one.
pass by value is a good one, yes. So it's almost circular, but a copy constructor is the kind of copy, it's the constructor that is used when the compiler, when the language needs to make a copy of your variable. So whenever you create a new instance of a class or a struct, a constructor is used. And a copy constructor is the one that gets used when you want to create an identical copy of an existing variable. And that happens because we explicitly say so in a function, but it also happens, the correct answer over there, when we pass things to functions by value. Okay, so copy constructors are really important, really fundamental sort of idea. And finally, a destructor. What is the job of a destructor? Sorry?
Reclaim the memory used.
Reclaim memory, that's a good one.
Destroy the constructor.
Destroy the constructor. Oh, not quite destroy the constructor.
Opposite of
Behave
Do-
like code.
Undo whatever the constructor did, effectively. And one of those things could be releasing memory. There are other things that you might want to do in a destructor. In general, we say releasing resources. So memory is one resource, but it could be a file descriptor. If you've done any Unix programming, it's important. You can run out of file descriptors. We want to release those when we're finished with them.
Does it automatically release thread?
A thread, you might want to, there is in fact a standard library class that's standard thread. But if you're doing it manually, if you're using p threads, posit threads, then you might want to destroy the thread or join the thread in the destructor.
You have to join it in the standard library too, or detach it.
Yes.
You'll actually get a nasty exception.
Let's not talk about that. So when is a destructor called? We have these natty functions called destructors, but when are they used?
You go out and
When you go out of scope, yes, absolutely. I'll talk about it again next week when we do the revision stuff, but this idea of scope-based lifetime is absolutely crucial to writing good C++. Using scopes to control the lifetime of your variables, because you know that when we exit the scope, all the variables will be destroyed, meaning those destructors get run. So again, destructors releasing resources. So capturing the resource in the constructor, releasing it in the destructor. It's an idiom, a pattern, for odd reasons called RAII, and it's sort of the fundamental idea behind how we write C++ these days. So anyway, default constructors, copy constructors, destructors, these things are collectively called special member functions. There are a couple of other special member functions that we haven't talked about in this class are added in C++ 11. Move constructors, move assignment operators. We will talk about those probably in the sort of advanced level course because, well, they're quite advanced things and we need a bit more background knowledge before we get there. But for the moment, you can do almost everything you want to do with these special members. And they're called special because, as we've said, the compiler will generate them for you if it can, if you don't write them yourself. As I said, in previous sessions we talked about default constructors, copy constructors, and destructors. The counterpart to the copy constructor is the copy assignment operator, which I'm going to natter about for the next few minutes. So, let's backtrack. What's assignment again?
Assignment.
Yes. What's what in C++ anyway? What do we mean by assignment?
Assign data.
Assign data to a variable. That's pretty good. I'll put it a bit more generically, perhaps giving a new value to an existing variable. Replacing the contents of our variable with something else. So, this analogy we've been using for weeks and weeks now about Word documents on your computer. It would be, you've got the existing document and you just copy and paste a whole load of new text, replacing what was already there. So we're not creating a new file, we're not constructing anything. If we were constructing something, we'd use a constructor. We're not, we're just replacing the contents of this existing file. And we do that, we write it using the equals symbol, single equals symbol. So double equals checks for equality, single equals in C and C++ is assignment. So here we have an int called I, initialized to 0, and we're assigning the value 4 to I. Replacing the contents of I, which was previously 0, we're replacing it with 4. It's assignment, that's straightforward, right? It's familiar, if you've done any sort of programming, you will have done this before. Nods, yeah, excellent.
You could also
It's
do
just
my
confusing why you call it copy assignment operator, where it's just an equal sign. Like it's
not quite.
you make it.
It used to just be called the assignment operator, right? And then in C++ 11, introduced this thing of moving rather than copying things. So there was a move assignment operator, but we're not going to be talking about that today. But that's why it's called copy assignment.
And yes, you could just do int I equals 0 and it would be the same.
There's a reason I didn't.
No, obviously it's still so distinct.
Yeah. So this equal symbol is an operator called the assignment operator, and as with almost every operator in C++, we can overload it to give it a meaning that we like, to make it do whatever we want to do, whatever we want it to do. So an example that we've been using frequently is the equality operator, equals equals. We've written that a few times for our own types. Well, we can, using exactly the same syntax, we can write an assignment operator. And we can write an assignment operator from any other type that we like. There's no limits on any other single type that we like. So we could have our class, if it made sense. So for example, standard string has an assignment operator that takes a string literal, because that sort of makes sense. You could say string s equals hello world, or string s equals hello, and then below you could do s equals world. Right? So string has an assignment operator from a string literal, a standard string that is, as an assignment operator from a string literal. But one particular form of the assignment operator that takes the same type that we're operating on as a const reference and returns a non-const reference to the thing we're operating on, that particular form is called a copy assignment operator. So in the same way that you can have multiple constructors that take different arguments, but one particular form of constructor is special and called a copy constructor, you can have all sorts of assignment operators, whatever makes sense for your class. But this one particular form is called a copy assignment operator. And the copy assignment operator is the special one, or one of the two special ones. It's the one that you'll get, the one that the compiler will generate for you. If this is a bit wordy and doesn't make sense, don't worry, I'm going to show an example in just a second. You don't have to memorize that. So this is an aside, but something that's quite important distinction to note. When we're constructing a new object, we use a constructor. The assignment operator is used when we're modifying an already constructed object. And this is a bit confusing because the syntax looks very similar. So here, we've got our struct example, and I've written the signature of a copy assignment operator. So this is what one looks like. So much as we did for operator equals equals, it's written as a member function that's named operator equals. Its argument type is const example, so the name of the class, const example ref. And its return type is a non-const example ref. This is the form, this is what a copy assignment operator looks like. So now we're default constructing an instance of example called E1 and another one called E2. And then when we write this, we say we set E1 equals to E2. This calls the assignment operator. Okay, E1 and E2 have been created here, so we're not creating anything new here. What we're doing is we're modifying E1.
So is it correct to say that the assignment operator basically tells you how to deal with the equal sign?
Yes. So the assignment operator tells us, yes, exactly that, what to do when we see a single equal sign like this. Okay, so what happens here is when the constructor sees this line, E1 equals E2, it will look in our class E1, it will look for something called operator equals that takes something of this type. in this case E2 is an example as well. So we'd look, you might have multiple operator equals overloads, but it's got one that is a const reference to an E2, so that's fine there. And then it will execute this function. And then it will return E1. That's what this return value is for. Now, in this case, in most cases, we don't care about the return value. However, it's standard, it's used so that we could, in theory, chain lots of these together and say E1 equals E2 equals E3 equals E4, which is pretty bad form, but it's just the standard way we do it. Yes?
I think in the last slide you said it has to take a const.
Mm-hmm. Mm-hmm.
But it doesn't take a const reference. It takes a reference.
So if you omitted the word const there, it's still a valid assignment operator. And in this case, it would be used because E2 is not const. However, if we'd written const example E2, we couldn't use it. So, and also writing it without that wouldn't prevent the compiler from giving you, the compiler would still write its own copy assignment operator because it would look at the one you've written and go, oh, that doesn't quite match up to the pattern I'm used to. So this calls the assignment operator. This line, however, we are creating a new example, called which I've called E3. This is constructing a new variable. This does not use the assignment operator, even though it's got that equals in there, because we're constructing a new variable.
So if you deleted E1 and then did E1 equal E2, this time around it will call the constructor.
If I remove this line, remove the line example E1 brackets,
And run auto E1.
and if I wrote auto in there, then that would be a constructor, yes, because we'd be constructing a new variable. So in this case, this is going to call the copy constructor, not the copy assignment operator. Assignment operator is only used when we're modifying an already existing variable. If we're constructing something, it uses a constructor.
What difference does the ultimate answer give? E2 is still equals. But if you'd rather than have it, for example, E3, E1 and E2. E1 and E3 is still E2.
Yes. So what difference does it make? Hopefully, if you've written your code properly, it shouldn't make any difference because the end result, it shouldn't matter whether I default construct E3 and then assign it, or if I just do it all, use the copy constructor to do it in one step. It shouldn't make a difference. However, it will make a difference in terms of which functions are called, right? So if you write this and you're expecting to see your assignment operator called, you might be surprised, if you hadn't listened to this, you might be surprised to know that it's actually going to call the copy constructor. But that raises a good point, that the copy assignment operator and the copy constructor are quite sort of intimately linked, and they should always do the same thing.
You have to reset the assignment.
You have to reset
You
in
might
the...
have to reset in the assignment. And you have to do the copy construct. So if you put something onto memory,
Yes.
you need to take care of that before you do the assignment.
Yes, you'd have. Well, okay, when I say they should do the same thing, what I mean is, for the end result that the user of your class sees, ideally there should be no difference between default constructing and then assigning, or copy constructing. Now, copy constructing, doing it in one go, will probably be more efficient because you're doing things in one step rather than two. But in terms of the end result, for a sort of well-written regular class, these things should be equivalent in terms of what the user sees. Now, again, internally, doing it in one step, the copy constructor is probably going to be more efficient because we're not going to have to create our initial values and then immediately overwrite those.
Are you thinking about unique pointer when you say reset?
Yeah.
So I mean, you're saying that, so unique pointer is a move only type. So if you want to make copy all type that wraps unique pointer, you can use the assignment operator on the unique pointer, and the unique pointer will delete the old object anyway.
No, I
So
just wanted to
preserve the semantics.
we had a raw pointer. For example.
Right, what?
The raw pointer.
Oh, raw you have to delete or you're leaking.
So anyway, the takeaway from this is if we're constructing a new object, it uses a constructor. The assignment operator is used when we're modifying the value of an already existing object.
Question.
Yes?
I get the second half. The first part of it, how would we say that in normal words? The struct example. So you're saying, yeah, struct example. You're saying the creating a construct called example.
So, yeah, I'm creating a structure called example.
A structure called
Struct,
example.
yeah.
With a reference example. With a reference to example.
Okay, so this is a function, a member function declaration.
Member function, I think.
Yeah.
So in normal words, in normal language, I would say a member function called example.
Operator equals.
So remember in C and C++, the return type of a function goes first, usually. So if instead of the operator equals, this said blah, then it would be a member function called blah, which takes a constant example ref and returns an example ref. Right? If it said blah instead of operator equals. That could, because that's the form, that's how we write a member function.
So there's nothing moving forward in C++, so you don't have to write the example ref more than once.
Here.
You can write it there and then write it again.
Because they're two different things. So this is the arguments that the function takes, and this is the return type of the function.
Oh, it's return type.
Yes. Yeah.
One in brackets is what it takes. The one not in brackets is what it's giving you back.
So this is
The return type is operator.
sorry?
The return type is operator.
No. This example reference, this is the return type. So when we write functions in C++, member functions as well, write the return type, function name, and then in brackets we put the arguments that the function takes.
The word operator is a special keyword in the language, so it tells the compiler, whenever I use the equal sign on this example type, please call this function called operator equals. You can literally call operator equals directly as if it was just a name, but it's also a special kind of intrinsic type in the compiler. It says, oh, you're using equal sign here, go to the operator equals function instead.
Oh. That's a good point, actually. If you want to be particularly obtuse, you could actually say e1.operator equals brackets the other thing. If you really had to for some reason. So as I've said, as with the other special members, if we don't write a copy assignment operator for ourselves, the compiler will give us one if it can. And the compiler provided version, all it will do is copy assign each of our member variables in turn, in the order in which they're written in our class, in our struct. And then it will return the object that we're operating. And I haven't written it on this slide, and I should have. It's, as with the other special members, we can use this equals default syntax to say to the compiler, please generate this for us. Again, if we get it by default, usually you might think, well, why do we do that? And it will make more sense when we come to talk about move semantics. But as with the other special members, you normally don't have to write your own copy assignment operator. If you think about this, copy assigning each of your members in turn, that's pretty much usually what you would want to do. So we usually don't want to worry about writing our own copy assignment operator, because usually the default will do the right thing. It's only if we're doing special things, handling resources that we need to do manually. So the example was memory, new and delete, and malloc and free if you must, all that sort of thing. File descriptors would be another kind of resource that we want to handle manually. And in that case, we'd have to write our own special members. So just give you an example of what, or a slightly more in-depth example of what a real copy assignment operator might look like. Here we have our struct example. It's got two members, int I and float f. And I've written a constructor, which takes an int and a float. You can probably guess what that constructor would do. I've written a copy constructor, a declaration of a copy constructor. Okay, so if you remember, constructors, special, they don't have a return type. It's just the name of the class, and then in brackets, the arguments it takes. I don't know why I gave that variable a name and not for the other constructor, but never mind. And now here's a declaration of the assignment operator. So it's not a constructor, so it does have a return type. The return type is always a reference to the class we're operating on. And then the argument is a const reference. Const because, if you remember, in C++, when we copy something, we don't want to modify the thing that we're copying from. Right, the two variables should be independent. Copying something should not modify the source. Right? That's kind of almost the definition of a copy, right? Because it doesn't, if you photocopy something, it doesn't blank the thing that you're photocopying, unless the photocopy catches fire. It doesn't modify the source. Creating a copy doesn't modify the source. So this is the source, and it's const, and it's a reference so that we don't copy it, right? Because otherwise, how would that work?
Why don't you return on your copy constructor?
Why is this here?
No, not why is it not on the copy constructor?
Because it's a constructor, and constructors don't have return types. So these two are constructors. This is a member function, a regular old member function that returns that.
In the first constructor, if you set the default value to the float parameter.
In this,
Yeah. So then you need to make it explicit. This constructor.
yes, if I put like float equals 9.8 in there, then it would be a good idea to make that constructor explicit, yes. Getting ahead on this revision already, aren't you? Okay, so these are the declarations. I'm not going to bother showing you a definition of these constructors, but I will show you the definition of the assignment operator, because that's what we're talking about. So in common with all the other member functions, when we write the definition out of class, we prefix the name of the function with the class name followed by 2 colons. So this is the operator equals that belongs to the example class. And then in the body, we take our I and we set it equal to other.I. So other is this fellow that we're copying, and other has 2 members, I and F, and so we're setting our I equal to other.I. Now notice we're not constructing any new values here. We already have our value I, which will have been set by the constructor, or perhaps modified along the way, but this is using the int assignment operator, the one that's built into the language. But if this was not an int, but some sort of other class, if this was a standard string, for example, then this would in turn use standard string's assignment operator. You're blank.
This happened. So you're doing example, type example reference, example.
Okay, so this here is the implementation of this function. This is the declaration. This is the definition. So you remember we've done this several times for functions and for member functions. We put a declaration, say, in the header, and we put the definitions, declaration in the header, definition in the source file. We could, if we wanted to, put the definition in the class, but in this case, I've decided to show you what it looks like written separately. Right, so this is the name of the function, and we read it as it's the function named operator equals that belongs to class example. Right, so again, if this wasn't called operator equals, it was called blah, we'd write example colon colon blah. The way you read this is that's the name of the function, in brackets are the arguments it takes, and at the front is its return type. So that's the general form for how we write functions in C++ and in C and Java and C# and various C-ish languages.
So that will be in a definition, its own file, its own definition file. That's the format.
This would be, yes, if in the, so this top bit would probably be in a header, and this second bit would probably be in a CPP file, in an implementation file, yeah.
So, okay, so when I look at those files, I should expect to pretty much see this format throughout.
This second bit in the CPP, yes. So we could imagine if this had some more member functions, they'd all be written like this. You'd see if this had, if this had a member function called foo, then we'd see in our implementation file, we'd see foo, we'd see example colon colon foo, the function called foo that belongs to the example class. And by the way, just to reiterate for people who weren't here, because the terms struct and class are basically interchangeable in C++. So I've used the word struct here to avoid getting into talking about member access, but whenever I say struct, whenever I say class, I mean struct, and whenever I say struct, I mean class.
There is also one key difference, so don't use class until you know exactly what it does.
Keep using struct for now. Keep using struct for now, or you'll see funny errors.
By default, if you use class, everything is private by default. So if that means something to you, go ahead and use it. If it doesn't, wait till we teach you that. Just struct, that's will be public.
Okay, so this is the definition, and we take each of our members. In this case, we've got 2, I and F, and we're modifying the value of our I. Now I could have written this arrow I if I wanted to make it explicit, but I don't need to. This refers to our I that we're operating on, and I've set it equal to the other value of I, and I've done the same for F.
It's like a setter, right? It's like you're just setting it's like a setter basically.
It's exactly setting the values of I and F.
So this makes things explicit.
Yes. Or you could see it as needlessly verbose if you.
And possibly error prone. Don't write code yourself. The compiler can do it for you.
Yeah.
It's not going to get it wrong.
So this is doing the work that we want the copy assignment operator to do. What we want to do is after we've copy assigned something, we want the destination to be set to have its value equal to the source. Right? In this case, the value, what we mean by the value is that int and the float put together. And we've set both of those members equal to whatever the source was. We're almost done, we're not quite done. We can't just close it here, because if we do, the compiler will complain. Because this function has this return type example reference, And conventionally, all we do is we say return star this. So this is a special keyword in C++. It gives you a pointer to the thing you're operating on. So the keyword is only valid within member functions. And it gives you a pointer to the thing we're operating on. It should be a reference, it's not, it's a pointer. Because it's a pointer, we have to dereference it with this star in order to give us a reference. If that doesn't make much sense, don't worry. This is just what we have to do in assignment operators.
I mean, imagine this, it's an expected idiom. If I have an int, right, I expect that it would be valid to do A equals B equals C. Probably not the most readable, but I should be able to pass through an assignment. By making it return a reference on your struct, that also makes that possible. You can have an free instance of example and do A equals B equals C. So that's why we return a ref. If it didn't return that ref, the result of the first equals would give us nothing back, so then it breaks the second assignment. So we return this ref so you can keep assigning if you wish to.
If you were doing that with a string,
Yes.
this, you just not, what do you get from the dereference string? You just get the first.
No. So this is a pointer. Right.
Pointed to the first element.
No. This is a pointer to the whole class instance.
So it only works inside your class's member functions.
Yeah.
Okay.
You can't use it anywhere. What are you thinking of exactly by string?
Jonathan's point is that
Because if your example was a string, if you're returning a string,
You can't.
you're copying.
No.
If
So
E1 was a string,
if you wanted,
you're returning a pointer.
no. So if you wanted to make example assignable from a string, so you'd set the argument to const string and other, yeah. You'd still have to return a reference to yourself. You can't return a different type as the reference. The result of the assignment should still be your own type. So you can make it take whatever you want. You can make your example take a string or an int.
Yes. So if other was a string,
So you can then assign from the string, but you still have to return
so
a reference to yourself.
You return a string at the point you return.
No. You always return your own type.
Yeah, you never return someone else's type.
Or a reference, a non-const reference to yourself.
Because you're assigning to yourself, you're not assigning to the string. You're just using the string to fill in something inside your own type.
It's a peculiarity, and in many ways it would be better if this didn't do this.
I mean, strictly speaking, the language might let you do it. You could probably return a string, but it would not be what anyone expects.
No.
Imagine if I have like an instance of example E, right, and I do E equals some string. I put parentheses around that assignment, right? I can then do dot after the parentheses that encapsulates that, and call a member function on my E, which I've just freshly assigned to. If you return a different type, I'm now not getting an E back that I can call stuff on. That would not be something I as a programmer would expect. I believe you can do it though legally. It would just be very confusing code.
So I'm creating three ints called A, B, and C. What's perfectly legal in C++ and in C is to do on one line A equals B equals C. And what this will do, first it will execute this, B equals C, and I will set B equals 2. And then afterwards, so B is now equals 2. And then afterwards it will set A equals B, well B is now equals 2, so it will say A equals 2 as well. And this works because the assignment operator returns an int. In reference, we can see. And pretty much all of these facilities in C++, copy assignment operators, copy constructors, they all exist in order to be able to make your types behave the way the built-in types work in C. So this is the way built-in types work in C, and C++ inherited it. And so the reason that the operator equals returns a reference is so that we can replace int with I don't know, my type, and have it still work with the same syntax. Now, whether you think this chaining up of assignments is a good idea or not, it's not, by the way. It's 30 years of established practice, and we sort of have to follow that. It'd be nice if we didn't, but we do. Anyway, this pattern, assign each of your members and then return star this. This is the sort of canonical example of what an operator equals looks like. And in fact, if I'd just written equals default in here and didn't have this bit, that is exactly what the compiler would do for me. So why write it myself? Well, I shouldn't. Why would I do work that the compiler was quite happy to do for me? This is to show you an example of how you write these things, to show you what the compiler is doing.
Yeah, so you certainly can change the return type to whatever you want. So you could deliberately break that by setting the return type to void, for example. The second equals will work, the one on the right will work, the next one will fail.
Can you try, if you do that, and then ask using type traits whether standard is copy assignable or whatever the type trait is called, see whether that's true.
Let's try. It doesn't work.
It definitely, I know it would fail in the concepts TS, but I'm curious. Anyway, for the last few weeks we've been working on this little thing. We've had these lines, and we've had this class line, and we've gradually added constructors and copy constructors and things to it. A structure at the end last week. If you haven't been here the last few weeks, you can go to this URL and git clone the repository there. And basically, what I want you to do is to add a copy assignment to operator. So we've done this several times now for the various other special members. So people who have been here the last few weeks will be quite familiar with this. What I want you to do is to add a copy assignment operator and verify that it's working correctly, by which I mean perhaps put a print statement in there saying class line was copy assigned. Right? And then in main.cpp, write a little test to copy assign your types and make sure that it gets printed out. And if you have done this before, so this by default doesn't have a copy constructor, but if you were here last week and you want to, and your class does have a copy constructor, you can do this last bit.
Can you go down one slide?
Down? Oh, you mean back?
Back, sorry, back one slide.
What, and put the answer up on the screen, you mean?
That's the answer. That's not. Well, I mean, it's like an example, not the answer.
It's exactly the answer. It's just been on the screen for the last 10 minutes.
Yeah, I can't memorize it.
What am I doing? Also, the answer is yes, it is copy assignable,
Oh,
but
right.
it is not trivially copy assignable.
Well, no, it won't be. If
Actually,
you've-
of course it's not, because you get going to operator. That is obviously with a void return type.
Yes. I can tell you that the concept version of that, what's in the concepts, or the ranges TS, it does check the return type.
So,
Using type.
I have a question.
Yeah.
So if
Anyone needs help around?
the copy assignment operator,
Yes.
if you do not explicitly guess the default,
If you don't explicitly write equals default, yes.
if you don't ignore the content
Yes.
at all,
Yep.
yeah? When you do A equals B equals C, what should happen?
The byte thing. Yeah, so if you don't write copy assignment, if you don't write
Anything.
anything,
Yeah,
then you get a generated copy assignment operator that will do the right thing. It will do what you want it to do. Copy assign each of your member variables, and then it will return stars. So it will do exactly what I did in that example.
Actually, I
Because
have,
And that will allow this chain up to work.
Whatever's happening in
actually,
the
I
code.
have this thing, the line,
I think.
remember?
Yeah.
I don't have a copy assignment constructor operator,
Yeah.
and I'm just A equal B equal C in it,
Yeah.
and it gave me a calculation.
Okay. Do you have a copy constructor?
Wow, I believe that
Okay. So one of the things I did mention is that if you write your own copy constructor, it won't generate a copy assignment operator. Why? Because I'm going to talk about more about this in a minute. But
So how
basically,
do you overcome that?
you can write a signature and then equals default.
Yeah.
And that will say pre-generated.
And then when I have one instance of that type,
The reason for that is because usually if you're doing something special in the copy constructor, you also need to do something special.
if I was to try and have an example, that would actually help the file.
So,
You cannot have a name in the same type.
Okay.
I'm not, I'm returning something. So,
Yeah.
line reference operator.
Which we call
So line
you don't want line code on code because you're inside the document.
Yeah, perfect. That's absolutely perfect.
And there you go. Idiomatically.
What over your shoulder as you do
Well,
it.
First problem you have is that you go back to your header decorations. So first of all, you want to be able to font version of the line.
So we want, actually we just want to
And then
right?
Yeah.
So
change
we
the
don't,
definition.
then we just, because this is
You write it instead of the brackets.
Saying in your
instead of reference,
main in
just
your
say
translation, it's default. So obviously update this to be the same. As I wouldn't have space to be equal to some distance. No. Join the symbols would be word operator. I don't think it matters, but just if it's operator, this operator.
Oh, so you're doing it
You need to give it a name that's access it. So we're taking the comments by name. Only actually access it. I would usually put something like RHS on the right hand side, other. It's obviously it's on the right hand side of the equal sign. So you're already inside your own instance. So what fields do you have inside your class? Just like the head kind of. It's not line, because you're in your own instance. You've got the start. So this is a member function, so you can either use this, or you can just call them out by name, or figure it out for you. So assign start from the right hand side is start. No, you can't assign start from the whole class. You need to assign start from the start in RHS. You want access. You want access to RHS. No. That's class fine. You're saying that our start should be set to the start in RHS. Yeah. So that one's done. We'll do the other one. And then you need to return elements to ourselves. So what's the keyword processing yourself? So just set P2 to P. You can't actually pass this to make a new one. Yeah, you can't even const once it's const, it's fixed stuff. Doesn't matter what you're assigned to. You just give it that. It's default constructor. Do you have default constructor? Yeah, you do. So you're fine. So you can do that. Because you're going to overwrite anyway. So you just declare a value in brackets, but you've already used that before to give it the name. By using it. And then assign it on the endpoints. And then just print out what's in it now to validate it.
very first time here.
Oh yeah, how are you liking it?
Yes, I like yes. So can you talk me how install C++ in my laptop?
Oh yeah, sure.
Because otherwise I would.
Yeah, yeah.
There's
No
too
worries.
many versions of C++.
Mhm.
I need to install.
Yeah, so we recommend C-Line. If you get connected to the internet, the password to the Wi-Fi's there, and then once you're up and running,
I need to get internet and I will just keep it.
yeah, the Wi-Fi password's just there on the wall and behind you as well, on these
We're
pillars.
supposed to come live. We're doing
Yeah, yeah.
We're doing it here.
Yeah, I'm doing it. Not about doing it in line. Yeah, line is it's still in.
Yeah, so just going to follow along.
Go back to the original.
Really beyond that, it's about value. Is that how you work?
That's right. So I think it's just this.
That's what is the best? Is in a
You use traditional. So,
yes, I use it as a
Line do line. Line do dot.
assuming you don't have to do anything else.
Okay, sorry.
You can pretty much you can't see the certain if you want to get extra stuff. Oh, so you do that, and you do your other dot in there.
No, wait, I'm just
Yeah. Oh, and you can do that.
you can even make it more functional to set it up.
Oh, like well, this is set up.
Oh, sorry.
Even though it's
I think you just need to give an example.
So that works then, right? That passing that.
so really should be I'm treating this as if
It's
I
called
have
music.
yeah.
Yeah.
Which is
Yeah, you just
so so
Yeah,
the syntax of the
Yeah.
call.
You just need to give an example.
And this is then
Question.
D and F.
But it can be constant line doing that. That's an issue.
Yeah.
So then you just say D.
C
I'm
and
not
Z.
sure if I agree with it. I can't compare it. You can't basically so you can't go always in so I don't want to try to switch to we go self-I line. That's the normal thing to say. Yeah, because with this it doesn't seem
Yeah, yeah, yeah.
I find it simplistic. But then if I call that I there, it's that's not valid.
That is absolutely fantastic.
Oh, but then how do you know what's not there?
It's the outer one because the outer one has to be there. You can't just like being on the outside has to be something like this.
So this stops this needs to be cool like these sort of like this device. Not just possible, right?
Inside, inside is then spaces. This takes precedence.
Yes.
You put this on. If I put itself, but we'll get into it. Itself, which is just in this means
I don't know, my phone is fine.
No,
I think it's because I'm using rechargeable.
I
think it's because they have a lower voltage than normal ones, so I think that.
Yes.
They're still probably better.
That's the important problem. Really
Rechargeable batteries are about 1.2
Sometimes mine sees it.
Yeah, I don't know. It's the same.
It just I can't do anything with it.
No. I can use them with this. Like, fail
Oh,
the
yeah.
same setting and restart.
yeah, so you can say the silent operator.
Wireless mouse. And I've got a battery which works.
Yeah, we're trying to assign a constant to something that's stuff. I'll access onto that.
The main text that we covered are regular content. So using this rule,
That's
we
enough.
call it
You
constant.
don't change operator.
Or now assignment.
So what we've been trying to teach is sort of how to write your own data structures.
to write your own types and columns. So you can imagine you have a struct student, string first name, string second name. And then this stuff about member functions is really about operators, constructors, destructors. Is to sort of show what the language is doing kind of behind the scenes, how things actually work. So
I've got different.
if you've written one of these structs, like student, for example, when you copy it, what's actually going on? Well, when you copy it, it's going to be calling the copy constructor. And if you like, you can write your own functions.
Just do make.
Generally, especially when you're highly visible, which is what we're going to talk about. So, in a sense, I guess the last couple of weeks is non-essential that you can apply without knowing. But it's definitely increasing your understanding and knowledge.
It's not outside.
So then are you saying that the best way to get it to speak with people?
Excellent, okay.
It's not really achievement.
Okay, that's a good start. Yeah, let's.
I would say the best way is one of the things at the beginning. The format for this is like a mini review snippet exercise. And even though I've been trying to build, so it's a bit harder to.
I mean, once you download it, you can come back.
Because next time you'll be done with also, right? I say this page again.
I mean, once you download it, you should never need to come back here, but you can. Okay, download it. I want to move the mouse away from there. Go down. That's it. Click the download button.
So that's why. That's why we have.
You can save or run it. Doesn't matter.
Outside of Tuesday classes, but it's just doing exercises.
20 odd seconds. Once that's finished, you just click run and go through the installer.
Right, so not just.
Just a quick.
This is what this is.
Yeah, sure.
This isn't.
But a bit more.
Okay. I'm trying to mess around.
Let's write a program.
Yeah.
Maybe put static on that.
Oh.
You know, and then you can naturally see how all these things that we've talked about, how they're used, why they're used, and how
But it's easy.
well, we can start off easy and build up. That's
Yeah.
kind of the point. So, in these sections, we can sort of impart the knowledge and say this is what exists, and these are situations where we use them. But as with everything, it settles in your brain a lot more if you can see it and move it around it.
Yeah.
I guess this is the example. This is the equivalent of a piano teacher getting you to practice scales.
Yeah, you're trying to use it as a static.
It's not a real piece of music. So you can do it and make your fingering
So,
keyboard.
Yeah.
And make your better piano.
You need an instance,
But if
and that is
so
what you're trying to
also
use
you need to balance
So
that
you have
out, then you're-
create a file.
You know what I mean?
Because I have this question.
Sorry, create an
You're
example.
defining the
Create
class
an
in one file, but then you're also doing a definition in another file. Is that not strange?
In every other programming language, yes, that's really weird.
Okay.
And it's just one of these unfortunate
Okay.
legacies.
Now do ff.file.
Maybe it's good to like I suppose to do.
Yeah.
No, it would be better if we didn't have to do it. It's more like Java or something. You could do it all.
C line.
I'm talking about the separation of interface and implementation.
No, C line.
It's kind of sucky. One day maybe we'll have modules and we'll have to do it.
Yeah, that
His name of software clean, yeah?
download.
C-line.
Yes, yeah, C-line, yeah.
Yes, yes.
C-line, yes. Yes.
Okay.
C-line, yes.
Excellent.
Yeah, let's do it.
How are people getting on with their copy assignment operators?
We've had a few successes already, hasn't it?
A few successes? Yeah?
With a little bit of help. Yeah, I mean, I did it all by
Yeah?
myself. Ollie didn't come through
I didn't spoon feed you, okay? Just enough to use what you like.
solve the whole problem. Okay.
Yeah.
I think it's not. I think it's too heavy.
So give a couple more minutes for people who haven't finished.
I will.
Yet.
You do definitely need to sure.
Do you not even 2D platform?
Like to make 2D stuff, it's very sure. Like this is the first.
Downloaded.
Coding. And then there's also the
Did you install it?
Oh, yeah, the visual of the game
It's not easy at all.
If you go to the top, and there's 10 usually shows the recent things you've
There is coding.
at the top of the list.
I don't know what you mean there is.
It's probably the top of the
What do you mean? What do you mean by 2D platform? Like 2D game?
list. No, you haven't installed it. Go to your browser.
Yeah.
Well, I don't know how to watch the video.
It's still
Maybe
downloading.
But the reason I
But if you're just doing something that just goes like this,
Yeah.
for long
you just
stretch,
copy
that
copy
doesn't
construct,
require
copy it,
like-
yeah. It's like
Oh, right. No. Yeah, no, you're right. In that, when you said it should do the same thing, I mean, the end result should be the same as the end user perspective. Obviously,
maybe it's just me.
what you're actually
but
doing
I
in the
find
function.
it like it's not that easy. It's like there's so many. Even though you have Unity, it's like
I'll show you. I'll show you.
game.
Well, sort of. But we should not maybe this. If I can get it out, I think it's the right seat. It's just a working thing. So
So you use no code.
so this I did. So I was talking to the developer. He said that's not
It's downloaded now.
He's looking at
You need to open it.
Yeah, that's where but he just said that you know, do a land firing program that's top the projectile.
You get on this next. Have you installed it? Go to your start and you see this now.
Okay, did anybody who was here the last few weeks try this last one? So somebody who had written their own copy constructor. Did anybody try? See what happens?
Same way you start work.
Ah.
Go to the start menu
It's alright.
in the bottom left hand corner.
I'll just wait for these guys to
Screen.
Everyone's still chatting.
Yeah.
Just comment.
Okay,
It doesn't
There
work.
it is. Checkpoint sea lion.
what doesn't work?
Like this comment out.
Yeah.
The comment doesn't work.
Well, you have to comment out both the declaration and the definition, but what doesn't work?
Yeah, that's fine. Just give it a
Something doesn't work, you're right. So, what I was trying to direct you to with this last bullet point is if you write your own assignment operator, so usually if you comment out your copy constructor, it's a special member function, so if you don't write one, you get one automatically.
Pick whichever you like the look of more.
However, if you write your own copy assignment operator, that will stop the compiler from
Which one do you like?
generating a copy constructor.
Okay, click on it. Yeah, okay. You can just click the button.
And the other way around. If you write your own
Okay.
copy constructor, it will stop the compiler from generating a copy assignment operator. And we can get that back by writing equals default on the one that would otherwise not exist. So it's saying why
Do you get two? Do you get two?
to
Two copy assigned operators.
no, that can never happen. There is but one copy assignment operator, and there is but one copy constructor. But why is that? And the reason for that is actually the language kind of helping you out. Because if you're doing something special in the copy constructor, so that you're not using the default one, you're using your own. If you're doing something special in the copy constructor, 99.9% of the time you want to do that same special thing, or something special at least, in the copy assignment operator. These things are in pairs. Right? If you're doing something special in the copy constructor, you need to do something special in the copy assignment operator, and vice versa. So that's why if you write one of them yourself, the compiler won't generate the other one for you automatically. Right? Because they're in pairs. Because there's this expectation that the semantics of your type, the way it works, is that doing a copy construction should work the same as default constructing followed by assignment.
Wouldn't it be possible to write one based on another one?
It's possible but not recommended for reasons that it's a deep rabbit hole, and I'll tell you about in the pub if you want afterwards.
So you always do both.
If you do one, do the other one. And in fact, there's a third. Because if you're doing something special in the copy constructor, and the copy assignment operator, you almost always want to do something special in the destructor as well.
Are we going to the next slide?
Yeah. This is like a clever lead on, right? It's a leading question from the exercise.
So you should just you could do
I think about these things sometimes, Tom.
no, you could just call the keyword and say the keyword.
If you implement one of the copy constructor, copy assignment operator, or destructor yourself, if you're doing something special in one of those functions, you almost always need to do all three.
So you could do
And this is called the rule of three, right?
So the difference is that the destructor will not be stopped by the compiler if you can.
Correct. That is correct. You always get a destructor. However, it probably won't do the right thing. If your copy constructor is doing something that is more than just copy initializing each of your members, if you're doing something special, then you almost certainly need to do something special in the destructor as well to handle that, to do the counterpart to whatever you were doing in the copy constructor. Right? And this rule was well known in C++ 98, old C++, it was called the rule of three. I've mentioned them a couple of times. C++ 11 gave us two new special member functions that were called the move constructor and move assignment operator. And these are sort of almost think of them as more efficient versions of copying, if you like. They steal the contents of the source object. Rather than giving us a copy, they steal the contents of the source object. We'll talk about those in a future session. We have to get into talking about R-value references, and it's all a bit messy. So we're not covering moves at this stage, but the point is that there were two new special members, and they also need special treatment. So now, if we're written any one of these, we probably need to write all five. So this is now the rule of three, which was C++ 98. After C++ 11 became the rule of five. That's a lot of writing. This one I like much better. The rule of zero. In general, it's best to structure your things in such a way, structure your code in such a way that you don't have to write any of the five special members yourself. Structure it so that the compiler generated ones do the right thing. Writing less code, that's good, right? Yes, yeah. No, it is. If the compiler can write it for you, brilliant. And this is referred to as the rule of zero. In general, don't write any of the special members yourself. And again, we'll go on to talk about in future. The thing that really helps and really enables this are something called smart pointers in C++ 11. So in particular, there's unique pointer and shared pointer, but especially unique pointer helps us abide by this thing called the rule of zero. So in C++ 98, if any of you have used it before or seen it, you very, very frequently had to write your own copy constructors, copy assignment operators to handle dynamic memory. And you had to do new and delete, and it was very hard to get right. Very, very hard to get right in the presence of exceptions. All that goes away with unique pointer, with smart pointers in C++ 11. The rule of zero. In general, do not provide any of them. But be aware, if you do, then you probably need to write all five.
How would you write a destructor? I mean, we looked at just destructor, just put squiggly line.
So how does one write a destructor? It's written, so it's a squiggly line, a tilde, followed by the name of the class, and then empty brackets. So it looks like a constructor, except that it's got this twiddly line, this tilde at the start.
Yes, but that's all you need. If you write your own copy assignment operator, copy destructor, all you need to do for your destructor is the squiggly line.
Well, that's the declaration. Of course, you need to implement.
Inside the squiggly lines, you need what you write.
Well, you undo whatever you did. So if you let's say you opened a file descriptor on Unix, you opened a file descriptor in your constructor, your destructor should close that. But then you have to think very carefully about what do you do when you copy your class. Because the naive way of doing it, the copy would, so a file descriptor, a descriptor in Linux is just represented by an int. So if you use the compiler-generated copy constructor, it's going to copy the int. So now you've got two classes that both have this int member, the pointer which is the same value. And then when you destroy them, they both call close on the same file descriptor, which is going to be an error. So how do you handle that? It's something you've got to think very carefully about. It's something that was very problematic in C++ 98. I've used the example of file descriptors because people seem to have a better handle on them than pointers, but all this applies to pointers to raw, to assigned memory as well, dynamically allocated
so
memory.
Really you just say you need the instructor to clear up your memory assignments.
Your resources, yes, of which memory is one. Yes, that is the job of a destructor, is to clean up any resources the class owns. Your instance owns, yes.
So the example of example,
The example of example, yeah.
would you just, in this particular case, you'd only use instructor equals default, right? You wouldn't write an empty one.
I've lost where my example was.
Yeah, this one.
Do you mean this one?
The destructor would just be equals default.
Yeah, I mean, this is a trivial example because it's got no members and doesn't really hold any resources.
Okay, so if you go to the one where it's int float.
So if you put a new in there for some reason.
If your constructor calls new, your destructor should call delete.
Okay.
But modern C++, your constructor should never call new anyway.
Yeah, in this example,
In this example,
you'd still call default destructor.
yes, you could do, so you'd write tilde example and then empty brackets because the destructor doesn't take any arguments. So empty brackets, and then you just do equals default. Because here we don't need to do any special cleanup of an int and a float. They'll just be destroyed for us. We don't have to do anything special.
And if you give it an empty destructor, that would be the same as well.
Yes. There are really technical differences, but yes, effectively. It would do the same thing, unless you were deliberately being obtuse and difficult.
So earlier you said, not back to back, but somewhere in your lecture you said, if you start a new resource in the constructor,
Yes.
if you call the new,
Yeah.
you need to call the correspondence, which is delete,
Yes.
to claim that resource in the constructor. And then after that you said, you should never call new in the constructor. Okay, so there is a little bit of a logical conflict,
Okay.
right, of that.
It's not, no. C++ has this facility, the keyword new in the language that uses heap memory, dynamic allocation, and returns you a pointer to some memory somewhere. And then it has a corresponding delete command which frees that memory. That facility exists in the language, and C++ 98 was the standard way of doing things. And you can still do things that way. However, we now have these things called smart pointers, which wrap up, do all that dynamic allocation for us. So when I said you should never do it, what I should have said was you should use smart pointers instead. Because smart pointers make life much easier, stop you from making mistakes, stop you from leaking memory on the one hand, or trying to delete the same memory twice. Errors that were really, really common in C++ 98 code go away when you start using smart pointers.
So you utilize a smart pointer in your constructor code?
Yes, exactly.
And do you still need to call the delete from the destructor?
No, because that's what makes the pointer smart. Because they will do the delete for you in their destructor. So the whole job of a smart pointer is to look after the lifetime of the dynamic memory for you.
So you only do the new, you never do the delete. If you use it.
Yes, because remember your destructor will run the body, and then it will call the destructor of each of your member functions in turn. And if one of those members is a smart pointer, the destructor of the smart pointer will call delete for you. So yes, sorry, that was confusing. When I said never, I wasn't being strictly accurate. What I meant was you should prefer using smart pointers. We have reached the end, ladies and gentlemen. We have reached the end of talking about special members. It's been 3 weeks. It's taken a while, but we've got there.
Especially as the end, you say never used
I thought I was thinking about this when I wrote the slides. It is important for you to know that these things exist, and it's important for you to know what the compiler provided defaults are doing. Yes, it's better not to use them, but they're there. The compiler's going to do this stuff in the background, and it's a good idea to know what's happening. It's your last chance, it's not really your last chance, but it's your last chance for today to ask questions about special members, or I'll get on to nattering about enumerations for the last 50 minutes or so. All right. Something completely new, completely different. Let's what?
I was going to say this should be fairly easy now. We've just covered.
Conceptually, this stuff is hopefully a lot easier than what we have been doing. So, let's start off. Let's imagine we're writing a little 2D game. A little sort of dungeon crawler, or maybe a text adventure. It doesn't really matter. We're writing a game where the player can move around a 2D map. Okay, and this is a turn-based thing that we're imagining. And in one turn, the player can move one square. North, south, east, or west. Right? This is fairly... Sounds easy. So, we want to write a function called movePlayer to perform this action. MovePlayer will do whatever it does. Maybe it checks if there's a monster in that square or something. It doesn't really matter. What we're interested in is the signature of this movePlayer function. So I've written it with empty brackets here. Of course, it wouldn't really be, because we need to give it a direction that we're moving it. We need to tell it, are we moving the player north, south, east, or west? So think about the signature of this movePlayer function. How do we tell it that we want to move north, or south, or east, or west? Well, here's one way we could do it. We could write a function movePlayer, and then we give it an int, which I've called direction. And then we say, okay, well, if you pass 0, that means north. If you pass 1, it means east. 2 means south. And 3 means west. From 0, because this is C++ and we count from 0. So who thinks this is a good way of doing things? Yeah?
I use strings instead.
You do strings instead. Right. This is a valid way of doing things, I guess, sort of. We have this function movePlayer, and we give it an int. And we have this comment that tells somebody reading the code what these magic numbers are. Then the trouble is, later on, someone's reading the code, and isn't reading our code, but is reading like another part where they're calling movePlayer, and they keep seeing this thing saying movePlayer 2, movePlayer brackets 3. And they're looking at that going, what? What do these 2 and 3 mean? And they have to go and look it up.
So moving player 2, obviously.
Yeah, exactly. So we can do this a bit better. We can write some constants. We can say constant north equals 0, constant east, southwest. Yes, you could use const extra if you prefer. And now we can say move player brackets north. Because north is this global variable that's set to 0. That's better. I mean, this is better than the first version of just writing that in a comment and hoping somebody reads the comment, right? Because now other code which uses this is now actually going to make sense in context. So you're going to see move player brackets east. That's easier to read. That makes more sense. I think this is better. There's a problem here. What happens if I do this? Well, which direction is 42?
Is it like modulus? Is it a 42 modulus thing that will just go continue until it finds the... No?
Maybe.
You don't know what the code's doing.
Maybe.
Whatever someone might have written.
Maybe you will run around in circles. Maybe you'll go to however many directions. Maybe it's modulo. Maybe it just does nothing.
Maybe it crashes.
Maybe it crashes. And that's the point. From the point of view of the compiler, this code is perfectly fine. We've declared a function move player that takes an int, and we're calling the function and passing an int. I've written 42. That could be 50 million, right? From the point of view of the compiler, this is perfectly fine. However, it doesn't mean anything. This is kind of semantically problematic, right? We don't know what... We know because we've sort of written that the int should be between 0 and 3, but the compiler doesn't know that.
It's error prone.
It's very error prone, exactly. And there's another problem, is that somewhere in another header, one that the person who wrote this move player code never saw, perhaps it's part of the graphics code, and it's got another set of these constants that says red equals 0, green equals 1, blue equals 2. And now you can call move player brackets blue. Because blue is just a constant, its value is 2. Well, that's all we asked for. We asked, can we pass an int to this function? If blue is an int value, well, why not? The problem with this is that it lacks any sort of type safety. We're using these magic numbers. And this isn't good code. This is error prone and easy to get wrong. Now you've probably guessed there's a better way of doing this. That's why I'm nattering about it, and that better way is to use an enumeration. So an enumeration is a way of assigning, if you like, semantic meaning to a set of, I've said numeric constants, that's not quite right, integer constants. And the key point is that an enumeration, or an enum, has its own type, which is distinct from any other type. So we've learnt how to define our own types as structs and classes. An enumeration is another kind of user-defined type. It's a user-defined type that consists of a set of integer constants. So for this example we've just seen, we could encode the compass directions as an enumeration I've got the word enumeration about 50,000 times in these slides, and if I'm tripping over it already, that's not a good sign, is it? Enum, yes. And if we do this, then the type safety rules in the language will prevent us from passing an int or from passing a different kind of enum into the function that expects a compass direction. So let me show you what I mean. This declares an enumeration called direction, which has 4 members, north, south, northeast, south, and west. And now the signature of our function, its name is movePlayer, it returns void, and its arguments is of type direction, this enum class, direction, which I've just called dir.
It's kind of like a drop-down list.
A drop-down list.
Like, as in, like, you can only put these.
A list of alternatives, yes, I like that, yes.
Can those north, east, south, west be const?
They don't strictly exist, they're just values.
Yeah.
It's like saying can 0 be const? 0 is just a number.
Yeah.
Yeah, but you can assign, so let's say north equals,
You can
let's say
have
20.
an instance. You can have an instance of direction, like you can have an instance of a struct, and then that can be const. The actual thing itself doesn't exist, right? It's just a declaration. It's a thing with the values.
Okay.
So now, this is the declaration of the function. How do we call it? Well, we say movePlayer, and then we say direction, : north. So this is the value, north, which belongs to direction. So this is saying movePlayer north. And if you didn't know that, but you just saw this in the code, you'd have a pretty good idea of what it was doing. Whereas if you just saw movePlayer brackets 0, that's a lot less clear. But what's even better is that if we do what we did before and try to say movePlayer 42, that's now going to be an error. Because there is no, as we've mentioned before, implicit conversion from an int to a direction. So if we try and write this, we're going to get a compile error.
Even if you write 0?
Even if you write 0. Or 1 or 2 or 3.
So underneath,
Yep.
is enum implemented as some kind of lookup table?
Underneath, this is just going to be some sort of thing like I had before with constant thing equals 0, equals 1, equals 2, equals 3. It'll be something like that. It's no more in terms of sort of runtime. This is exactly the same as if we'd used an int in terms of how computationally performance. Yes, what it gives us is a lot of added type safety.
So when you call it movePlayer direction north,
Mm-hmm.
it goes to the class definition. But then do you need to send it off to subroutine to do its stuff?
Yeah, so the implementation of movePlayer will look at the dir value and decide what to do.
In your CPP file, you've got a movePlayer direction.
I've got the implementation of this function will take whatever behavior, maybe there's a monster in that cell that kills the player or...
So if dir equals north,
Yeah.
Or a switch
then
case.
we'll move one step up.
Yeah, exactly that, yeah.
You could either implement this as in movePlayer, right? It's either going to be an if else, so if here is
We'll get there.
very up See, power of prediction, right?
Well, there aren't many places you can go with enumerations. So.
Yeah.
Right. Yes.
So if you had a more complex game
Mhm.
and you had northwest, northeast, so you had subcategories.
Well, you could have 8 directions instead of...
But so what if you had hierarchies? Now you'd have to use a table, right? You'd have to have a lookup table, right?
You can't have any sort of inheritance with enumerations. So in a more complex game, well, you might want to have north, northeast, east, southeast, south, southwest, whatever's left. So then you'd be able to move in 8 compass directions rather than 4.
Yeah. But so in coding, moving from enums,
Mhm.
the next step would be some sort of lookup table, or when you have hierarchies. If you don't have everything on the same level.
Well, that's usually more something like a game state machine, though. You probably still keep you say north, south, east, west. You have a state for, say, what level they're on. Right?
So, all right, so
it's a much different concept, though.
let's say we want to, and this really has nothing to do with enumerations, but just let's say we want to encode a move, a player move, and that would be a direction and a distance. What we do is we'd write a struct, and that struct would have 2 members, and one would be a direction, and the other member would be an int state to encode the distance. And then we'd have move player, and the argument type would be like move info or whatever the type is called. So this gives us added type safety. We can no longer pass any arbitrary ints into this function. But what's even better is that imagine a more complex game and I don't know, the player can cast spells. And the player can cast spells using an element. So you've got earth, air, fire, and water, right? Yeah. So you've got 4 element types that you can cast a spell on, and one of those is called fire. But you've also got actions the player can take with their weapons, and one of those is called fire. So you've got 2 different constants, both called fire. Well, if we were doing what we did before and just using these constants, that would be kind of problematic. Because now we've got 2 constants, both with the same name. These, what are called scoped enumerations, these, what you see here, the enum class, that gets rid of them because what we'd have would be, we'd have elements, : fire, and we'd have action, : fire. So they're different types, and we wouldn't be able to pass one sort of fire to a function that expected the other one. So enumerations are about enhancing type safety. So as you've just seen, we declare an enumeration using this weird combination of keywords, enum class. You can actually say enum struct as well, which is a little known fact. Nobody does it. You never see it in code, but technically it's allowed. You can also just say enum. That's the syntax inherited from C, and older C++ used it as well. That's an unscoped enumeration. There are differences between scoped and unscoped enumerations, but the long and short of it is, prefer this one, prefer the newer ones. If you're really curious about it, you can look up what the differences are. But basically, say enum class rather than just enum.
I mean, the short of them is unscoped really means that this is not 100% accurate, but to paraphrase, regular enums are quasi-magically global, so your north, south, east, west is now just magically accessible without stating the actual enum class in front of it, which is generally not good. It's not safe.
So in other language, when you do an enum, you sometimes can do a little description after it. Like, your north can be, I don't know, going up from the game.
It's a code comment.
Yeah, so C++ enumerations, even this new enum classes, are really quite dumb. They're giving names to integer constants. Now, newer languages, things like Swift and Rust and well, pretty much all of them actually, they have much smarter, much more powerful enumerations. They're, and they have things like pattern matching that make these things much more powerful. In C++, enums are pretty dumb. However, they're still useful for giving us type safety where otherwise we'd have to use magic constants. That's really their purpose in C++. So, yes, they lack almost all the facilities that newer languages have. They're really quite a dumb tool. But that's pretty good because it means I can explain them in about 50 minutes, hopefully. Anyway, you can use just enum. We'll give us an old style unscoped enumeration. It's better to write enum class. However, do not be fooled. This says enum class. It's got the class keyword in there, or you can write this. However, it is not a class or a struct. We are not declaring a class. We are not declaring a struct. It has pretty much nothing in common with structs or classes except that it's got the word in there. There are very few. It's the barrier to putting a new keyword into the language is extremely high, so they try as hard as they can when introducing new facilities to reuse existing keywords. And in this case, they decided that when they wanted to introduce this new type of enumerations in C++11, they decided they could do so by reusing this keyword. It's a bit misleading. When you say enum class, you are emphatically not declaring a class or a struct. You are declaring an enumeration, which is a kind of user-defined type, but not a class or a struct. Have I said that? Is that emphatic enough? So, the members of an enumeration, of an enum, are called enumerators. And each enumerator represents an integral constant. Right, so back before we said constant north equals 0, constant east equals 1, etc. All an enumeration is doing is giving special meaning to those constants. The enumerators still have some sort of integral value, and if we really want to, we can convert back and forth between their integral value and their enumerator representation. But if we don't assign a value to it ourselves, the compiler will give them values for us. So for example, we have this enum class color, and we've said that red has the value 10. I don't know why, I don't know what 10 represents, I just picked a number. And now we said, okay, we've got another member green. This time we haven't given it a value, so the compiler just gives it one greater than the previous value, 11.
For example, can you use minus numbers?
Yes.
Because obviously, if you were doing north, south, east, and west, you could have +1, -1, +1, -1. The directions, perhaps.
They don't actually have to be unique.
Are you serious?
Yes.
Then you're
Which, no, well, they don't have to be unique. You can give two enumerators the same numerical value. Well, the reason for that is that you can, in a sense, imagine you've got some C code, say, that uses just magic numbers. You can use an enumeration to give these things kind of friendly names. But you might have two meaningful names for the same thing. For example, the key on the right-hand side of your keyboard is the enter key. It's also the return key. So if someone says, like, key : return, you want that to generate the same low-level code as if they said key : enter. Because return and enter, we generally use them as synonyms for the key on the keyboard. It's giving two enumerators the same value says these names mean the same thing.
realize this is also
Of
1
course,
minus 1
of course,
is-
you wouldn't do that. No, of course, because those are 4 distinct sort of ideas.
Well, you could. You have a coordinate when you move the player. You move the coordinates. As per
But if you just saw move player, and if north and east represented the same direction, that wouldn't really make any sense.
We have in coordinates with XY coordinates.
Yeah, but then you're getting away from using enumerations. Anyway, yes, we can assign the integral values ourselves. They don't have to be contiguous. We can pretty much make them whatever we like. So we can say red equals 10. We haven't given this one an initializer, so it'll automatically get that. And then we can say blue equals 99. And then I've added another one, yellow. And again, this will give 1 more than the previous value by default. So these are just named integral constants, but wrapped up in a special type. And it's possible to convert red into the value 10 by writing a static cast. So for example, I gave you an example earlier of if we're calling some C code that expects an int that represents a color, we prefer that to wrap that up in an enumeration because we know only certain values are acceptable. And we can use a cast to convert color : red into the value 10, or color : blue into the value 99.
So web dev experts know though, red is really FF0000.
Well, it could be, yes.
It literally could be, yeah, you could do that. You could store RGB values.
Yeah. What have I got left here? So, enumerations is a very long word for what's actually quite a simple concept. You know, well, compared to talking about structs that we've been discussing for several weeks now. Right? These are just ways of defining constants and wrapping them up in their own type. So, it's actually worth saying all these things must be ints. So you can't have an enumeration of floats or strings or anything else. As we were saying, other newer languages have much more powerful enums. C++, they're really dumb. They're just ints. But ints wrapped in a new type that gives these constants some sort of meaning in your program. So, we have 23 minutes left. I wrote this nice, well, I don't know if it's nice. I wrote it anyway. A little exercise. In the README, there are 2 exercises. I'd like you to try and do exercise 1. I'm not sure if we'll have time for exercise 2. But nonetheless, you can take it home and have a go at it, if you like. So if you go to this URL, I didn't want to put it on GitHub Classroom because we had some problems with it last time I did that. But if you go to that URL, there's an underscore in there. It hasn't come out very clearly because it's underlined. So enums _ exercise. If you go to that URL, clone the project, and hopefully the README file should make sense. So if you have any problems, give me a yell, or Ollie once he's actually read the exercise.
Right. What a coincidence.
Yeah. Hard thinking of what to.
I don't know if you read it. I hadn't read it. I have not read it and then just started spouting about, you store red as evidence. Great minds, man. Okay.
Trying to get it to the loop. Does that make sense, those who have read the README? Hmm?
How many change font, because that is too small.
We shouldn't stand in the way. What are you trying to do?
I'm going to change that as I make it bigger because I don't see it.
Yeah.
When you say
Oh.
LS, yes, but I cannot change font and code.
Oh,
I change this is.
that's strange.
Yes. I'm going to make it bigger, I don't see it because I have problems.
Yeah.
Sorry for asking so
No, that's a good question.
I cannot just.
Maybe in the editor. Fonts. Here we are. So size, change that to something different.
For example, 18.
18 you had.
Yes. 18 because I have problems with this.
Is that better?
Yes, thank you. But also, this missed first time here, I missed previous lessons. Can you just different exercise for first lessons?
Yeah, sure. So if we go to, if you've got the browser,
Yes, the browser, yes.
So just go to the,
Very first lesson.
oh, that's fine.
So
Okay.
can you just save this page to my favorites? Yeah?
Yeah, so,
I just save it for favorites. It's for yes.
okay.
Save it because next time she's fine.
So what I was just going to show you was, so it's this repository here.
Okay.
As we have all the slides from our previous weeks, so you can read.
Okay. Can you go back? Okay. So this is.
Go back one more. Okay. So that has
This is
slides from previous weeks.
So I saved my favorites. Okay.
Yeah.
Excellent. So next time I will find myself. Thank you.
Well, I haven't taken the laptop anywhere other than here last week. So,
No.
Really?
oh, that's
Not really. Okay, I checked the books. Yeah, but we will go through it.
Actually, it's my first language. First language. Not is actually first language.
So you,
No, so I didn't know.
so doing
I was doing first physics. For physics, it's doing coding sometimes. I didn't know index. I didn't know index. I know everything.
still
Yeah. Yes.
And then it's just this is just the break.
Perfect. Yeah, that looks absolutely right to me.
I've done that. Let's add an overload set colour.
So we've got this member function set colour that takes 3 hints.
And then they
So
go
we need to add another version like a convenience function. So rather than somebody having to write for 3, they can just as a shortcut. So
Set colour.
add a new member function, also called set colour. So we want to return void. So you want to take an argument of type enumeration.
Does this need to go above?
Yes. Very good. Okay, we will just use exactly the same thing. So remember that in C++ we need to declare things before we use them. So this is reading from the top of the file, it gets to this thing colour, it doesn't know what it means. So all this means is to cut that out before.
Okay.
No side constraint. Oh, no. Call this E.
Not sure about this.
So
Colour.
okay, so you're saying this function takes an argument of type colour,
Which is
one of
defined by
those.
Yeah.
So we have to give this argument. So colours. So now C is going to have one of those three values.
Okay.
So that's what we have to do. So if
So C dot red or C red. That's going to be whatever that is. Set cut. I can't call set cut.
you can call the other version of set. So this is another version of set. It takes three values. So what I want you to do is if C is equal to
So it's just that 3 times.
No, I think you will find them on the website.
C. Question mark. Just looks nice. I personally think. But there's no null return. That's only
you can sort of nest the question mark, but it gets messy.
It does, doesn't it?
So
So, yeah.
I recommend using it.
Yeah.
Git.
What if we just do diff? Lots of diffs.
So if you just what's going to happen is you get to that edge.
Yeah.
So you read that, and then you'll execute the second sentence with that if statement, and then you'll execute the
Yeah.
third statement. So if you pass red, it's going to still execute the three statements. If you use else,
It'll
get
stop
the other two if statements. The other thing you can do is return that just like that. The alternative.
Oh yeah, that's true.
So you listen to the bracket after an if statement, you have to use brackets.
She's saying that. Could you use a switch?
That's exactly what exercise does.
Okay. I've got to use as well.
Make sure you've got the brackets matched. Now I just need to use yeah, so if you look in the name, just replace that set colour 00127.
Just maybe 1, 2.
Just click on this and delete. Just need to delete that.
Yeah, because I couldn't get into that.
We're trying to follow the same set colour and passing it. We've got two versions of set colour. One which takes 3 and one which takes 8.
Oh, you should call it correctly.
Hold on.
You got. Oh, yeah. So can you declare it? I declare mine in the header.
I googled inheritance and enum, and it said there's something called inherit enum. Yeah.
You can set the underlying type, which looks a bit like inheritance, but it's not really a
Oh, I could have. It's a header. Or students is
Loading, but see that way a bunch of stars.
new colours. Yeah, it's not like it's not really colour. Oh yeah. Well then I was just going from there. Yeah, it's right here. It's already like that.
Yes.
Okay.
Everything.
You know, especially
Can you
like
make it brighter? Yeah, I just think that's pretty cool.
it's O R. Yeah. So it's you like colour. So yeah.
I don't know.
Not
I
quite.
mean, she's
It's you can play this. You can also. That is what that yeah, this is the decoration. So you're not decorating, that's the
it's red.
you need to you didn't
Okay.
So,
that's the issue. It's not an instance. One which is really it's yeah, it's kind of it's just saying that no, it's not
Oh, okay.
so this is quite clever. So it's using actually a class. It's one of those ways in which C++ lets you do almost anything. Right. Okay.
Anyone needs help?
Okay. So let's see okay, right.
So, do you have your courses
Yeah, no,
so
that's
courses obviously here, but our previous, so the exercises on GitHub, key information. Courses on GitHub, recordings of these sessions. Yeah, so this is live right now. So once we stop it,
I have for lectures, I found lectures for first lecture 1, 2, 3, 5, for lectures, yes. But now I'm trying to find something.
maybe for our newsletter or that's registering from RSVP. So if you want to attend, so sometimes we don't host these events here, and then rather than registering with Skills Matter, obviously you have to do it directly with us. So that's what. So I think we're here for the next few weeks, so you can just do it directly with Skills Matter. I think the beginning of September we're not getting something like that, and then you'll need to RSVP for us.
So this is actually.
Yeah.
Have you got all the other times for this session?
Got what?
Current settings.
that's incredibly clever.
No, it's a separate repo, so the repo for this exercise is that one.
But what about the first one? Because you got Twitter and I don't recognize
I think you might have to put it on a different group.
Ignore this. This is me trying to do that. So my error is that.
No, just to get on to it.
It says it's not visible. So I mean, doing change the way post build. So yes.
Oh,
It
right.
says this is the font focus function.
Ah, okay, this is going to be not easy. I think that's the first exercise. But this shows Yeah. But these other ones, so if they have the same definition.
Say going to not in chronological order.
But you see this name here
Yes,
matches this name,
yes.
but this is This is another user using GitHub Classroom. Their code is in here as well. So it's not very well organized. Don't worry, just I will do it random, don't worry. I don't do random, no problem. So you start with this one. Yeah. This one. Okay, first. Okay. This is the first one. You finish. This is the first one. It's a save to my favorites, yeah? Because next time I should to find again. So begin at the
So change your It's the same thing.
Is that you can see it's not only Okay, we'll have to leave it there. If you are curious, we were going to go on to talk about switch statements as you would have gathered from exercise 2, but I will put all the slides online. So, there we are. Well, thank you everybody for coming. Yes, I actually will do it, Lauren. I promise. But thank you everybody for coming, and we have to rush off because we're a little bit past time. But thank you everybody, and see you next week hopefully for some nice revision and some don't think of it an exam, just progress reports maybe. All right, cheers guys.
So just a quick reminder before we go.